Factoring quadratic expressions. So factoring is separating a polynomial back into a product or multiplication of two or more items. So for example, we can factor 4a squared plus 8a into 4a times a plus 2. Polynomials that cannot be factored are called prime. So for this example over here to the right, we have this factored form. So this is something that has already been factored, and we're going to place it into standard form. So this is something you have done before. So x times 3x will make 3x squared. X times 10 will make 10x. 1 times 3x makes 3x. And 1 times 10 makes 10. And then you would combine your like terms together to get 13x. And then you still have this plus 10 and the plus 3x squared. Now, factoring takes this here and works backwards. So it starts with this 3x squared plus 13x plus 10 and works backwards into this as your final answer, which is what we're going to do in this next step. So if you notice, example 1 was the ending result that we had in our first example. So our answer for example 1 should be x plus 1 times 3x plus 10. Here are the steps on the left for how to factor using grouping, also called the AC method. These two names are used interchangeably. So these steps look really confusing, but we're going to do them over here on the right with example 1. So we're going to factor 3x squared plus 13x plus 10. So the first thing I would always do is look and decide, do you have a common number that you can divide out of 3, 13, and 10? So in this case, we do not. 3, 13, and 10 have no like factors, and so we have to leave this as is. So to actually begin factoring, we're going to multiply a times c together. So this is the a, this is b, and this is c. So we're going to multiply 3x squared times 10. So 3x squared times 10 makes 30x squared. Now, we have to find two numbers that multiply to be 30x squared, but will add to be the b value, which in this case is 13x. And so I'm going to start at the top of my list of factors with 1. So I'm going to say 1x times 30x. And if I multiply those two, I do get 30x squared. But then I'm going to make sure, do they add up to 13x? So if I add 1x and 30x, we get 31x, which is not what we need. So we're going to move on. 1 and 30 are not the numbers that we need. So then let's try the next factor, 2x times 15x. 2x times 15x does in fact make 30x squared. Now we're going to add them up and make sure and see if they make 13x. So 2x plus 15x makes 17x, which again is not the correct value. So we're going to go to the next factor. So the next one we have is 3x times 10x. So if I multiply 3x times 10x, I do get 30x squared. So now we're going to make sure what happens if we add them. 3x plus 10x. If I add those up, I do in fact get 13x. And so the numbers that we need to start this factoring process is 3x and 10x. That's step 1. Now, step 2, I'm going to rewrite my problem just so I have some space to work. Step 2 is, now that you know what numbers you need, the reason why we had to add up to be the b term is because we're going to take 13x and we're going to break it up into 3x plus 10x. Those two are like terms. If you add these up, you should get back to 13x. And the other stuff follows down with me. 3x squared on the front and 10 at the back. Now I'm going to take a minute and pause the factoring process, and I want to show you what you've done. What you have done is you've taken this standard form and you've gone back one step. You have uncombined the 13x to the 10x and the 3x. We've uncombined this to 10x and 3x. So our final answer is almost there. I need it to look like this thing above, x plus 1 times 3x plus 10. Now, to factor this, to finish this off, we're going to group these together. So what I mean by that is I'm going to group these first two, and I'm going to group the second two, okay? Now, the first two, think about a number and a variable possibly that you can divide from 3x squared and 3x. Well, on the 3's, I know that I can divide a 3 and a 3 by a 3. And since the front term has x squared and the last term has an x, I can divide out at least one x from both. This is called the greatest common factor. So the greatest common factor is a 3x. So that 3x is going to be pulled to the outside of my group, and I'm going to see what is left over. So 3x squared divided by 3x makes an x. And then 3x divided by 3x makes 1. Now we're doing the same process with the other two terms. So 10x and 10, what can I divide out of both of those? Well, they're both 10s, so I can divide out a 10. Now I cannot take an x this time because this has an x and this one doesn't have any x's. So they do not share an x. So the only thing I can take out is a positive 10. Again, to the outside of the parenthesis. And then let's divide out to see what's left over. 10x divided by 10 makes x. 10 divided by 10 makes 1. So now what we have left is we have basically two very large terms. So remember, terms are separated by addition or subtraction. So this 3x times x plus 1 is a term, and 10 times x plus 1 is also a term. And so what we have then is we need to look. And I noticed that this has an x plus 1, and so does this. So just like we divided out the greatest factor here, the greatest common factor of this term and this term is the x plus 1. So we're going to divide out x plus 1 on both terms. Just like before, x plus 1 will come to the side of a set of parentheses, and let's see what we have left. So if I divide out this x plus 1, all that's left is 3x. So 3x is left inside. And then again, if I divide out the x plus 1, all that we have left is 10. And now that I have gotten two things multiplied together, this is the factored form right here. And if I look, that's exactly what we started out with at the very beginning of this first example was x plus 1 times 3x plus 10. So the process of factoring is getting from standard form and breaking it back up into whatever was used to multiply it to get to it in the first place. Now, you can always check your answer by multiplying factored form back into standard form. Okay, let's try example 2, because example 2 is a little different. So for example 2, we've got factor to negative 2x squared plus 6x plus 18. Well, to factor something, the a value must be positive. That's the first and foremost. So in order to make a negative 2 into a positive 2, I have to divide out a negative 1. So again, the negative 1 comes to the outside of the parenthesis, and let's see what we have left. We're going to have a positive 2x squared, a negative 6x, and a negative 18. Now, before we move on, let's see. What else can I maybe divide out? I see I have a 2, a negative 6, and a negative 18. All three of those are divisible by 2. So I'm going to pull out another common factor of 2. Just like the negative 1, the 2 is going to come to the outside, multiply to the negative 1 that is already outside, and then let's see what is left. 2x squared divided by 2 makes x squared, negative 6x divided by 2 makes negative 3x, and negative 18 divided by 2 makes negative 9. Now that we have gotten the inside, the trinomial, the three-termed expression, as simple as possible, we're going to try to factor this out. So we're going to start the AC process. So this is your A, B, and C. So we're going to multiply A times C together. So we're going to have x squared times negative 9, which will make negative 9x squared. We need two numbers that multiply to negative 9x squared, but will add to be negative 3x. So let's start at the top of our list. Negative 1x times 9x. That multiplies to negative 9x squared, but if I add them, negative 1x plus 9x makes 8x, which is not the number that we need. So let's try another one. The next possibility is negative 3x times 3x. That also multiplies to negative 9x squared. But if we add them, negative 3x plus 3x, we end up with 0x, which again is not what we need. Well, there's nothing else that multiplies to negative 9. These are the only two numbers that multiply to be negative 9. And neither one of them gave us the correct value of b. So since there are no more factors, we have to say that this does not factor. This little piece here is not going to be able to get any simpler. This guy does not factor. So your final answer for this one is just 2 times -1, which makes -2, and then times x squared minus 3x minus 9. That's as factored as it will get. It won't go any lower than that. Now let's look at example 3. I'm going to help you start it, and then I want you to do some pieces on your own. So 12x squared minus 22x plus 6. First and foremost, see if you can divide a number out. In this case, we can. We can divide out a 2 from all of these. So the 2 will stay on the outside, and we have 6x squared minus 11x plus 3 left over. Now we can start our factoring process. A, B, and C. So we're going to multiply A and C together. So 6x squared times 3x gives us 18x squared. And I need to find the numbers that multiply to 18x squared, but will add to be a -11x. Pause the video to try to find your two numbers that multiply to 18x squared and add up to -11x. And you should have come up with a -2x and a -9x. So for +2 and +9, we ended up with a +11 when we added them together. So that meant we had the correct numbers, their signs were wrong. And so we take both numbers and flip both of their signs and try it again. -2 times -9 still makes +18x squared, but when you add a -2 and a -9, you end up with -11x. So the next step in the process is to use those two numbers and split apart the b term. So we end up with -2x minus 9x. And then everything else will drop down. Okay. Pause the video, try the next part in the process. The next part in the process is grouping together the first two terms and the last two terms and finding out the common factor for both sets. Pause the video, try the next step. And you should have come up with this. So the first, you can take out a 2x, and that goes to the outside, and then you're left with 3x minus 1. The second set actually had -3 in common, because remember, I need this front number to be positive. So -9 divided out of -3 gets me to the correct +3x on the inside. So we took out a -3x, and we end up with 3x minus 1, and then we still have the 2 hanging out on the outside. Pause the video, see if you can find the final factored form. And here's the final factored form. We have the common factor of 3x minus 1 on the outside, and then the leftovers on the inside. 2x is left over, and so is -3. And then the 2 from the very, very beginning still tags along on the outside. That is your factored form. So we actually have three factors. We have a factor of 2, a factor of 3x minus 1, and a factor of 2x minus 3. So once you try number 4, start to finish on your own. There is not a term that you can take out of number 4, so you have to do it as is. So pause the video, try example 4 from start to finish. And here's what you should have had for example number 4. Pause the video and try example number 5. Remember to always check and make sure, see if you can divide out a number from 3, 9, and 84 before you begin. You may be able to make your numbers a lot smaller. And here's what you should have had for example number 5. If you'd like, if you still want one more for practice, you can pause the video and try number 6 as well, if you need some more practice. And here's your factored form of example number 6.